let's proceed with the next problem wherein we would be having the unbraced lengths already. So in this problem, an A992 grade 50 W10 by 30 member with no hole. So once again with no hole. So meaning our PC here would be gross sectional yielding state. Okay, so it has an unbraced length of 4 meters. So meaning our LB is equal to 4 meters or 4,000 mm. And the member is subjected to tensile service loads of PD is equal to 135 kilonewtons. So this is to be for dead load. And for live load, that is to be 230 kilonewtons. And for service moments, as for the flexural moments, this would be its service moments. So that is to be 30 kilonewton meters for the dead load and 55 kilonewton meters for live load. And if our CB or our magnification factor is equal to 1, is the member adequate in LRFD? So this time we would be solving for LRFD. So once again, we would be making use of these equations right here. But first, we must check our value for PR over PC if it is less than or equal to 0.2, so that we would know on what formula we would be using here. So for our PR right here is equal to PU, since PU is what we would be needing if we are to solve for its interaction formula using LRFD. So LRFD tayo. So from that is to be 1.2 times PD plus 1.6 times PL. So equal sign 1.2 times PD, and our PD is equal to 135 plus 1.6 times PL, which is 230 kilonewtons. So solving for this, so 1.2 times 135 plus 1.6 times 230, our answer here would be 530 kilonewtons. So 530 kilonewtons. So we already have the value of PR. And as for our PC, so same, it does not have any holes. So our governing factor here would be gross sectional yielding. So for gross sectional yielding, that is to be phi PN. And our value for phi is equal to 0.9, since we are to consider a yielding limit state. And for PN, that is to be FYAG. And our Fy right here, so it is already given, 345 MPa. And our AG is 5,700 millimeter squared. So once again, this AG right here was copied from the AISC shapes database. Okay, so solving for this, 0.9 times 345 times 5,700, our PC is equal to 1769850 newtons. And if we are to convert this into kilonewtons, so we would be dividing it by 1,000. So that is to be 1769.85. So I would just be writing the conversion factor here. So I would be dividing this by 1,000. And so from that, it is now equal to 1769.85 kilonewtons. So that is to be our value for PC. Now solving for the ratio of PR and PC. So PR divided by PC, that is equal to 530 kilonewtons divided by 1769.85 kilonewtons. So our answer here would be, so from the calculator, 530 divided by 1769.85, that is equal to 0.299. So yung pen ko? 0.299. So the question is it greater than or less than 0.2? So it is greater than 0.2. So with that being said, we would be making use of this equation on the top, which is PR over PC plus 8 over 9 times the ratios of the moments. So from that, we already have PR, we already have PC. And as for our MRX, by the way, our moments here would be about the x-axis. So we would be making use of this factor right here. I mean, this fraction right here. And as for this fraction right here, which is concerned only with the y-axis, we would be removing this since we don't have moment about the y-axis in this problem. But if you have, syempre, isasama nyo. Okay, so I would be copying this once again to the next slide. Okay, so for our MRX, so by the way, I would just be copying this once again. So etong values natin na to. Sige, mamaya na lang pala. Okay, so for our MRX, so that is to be the factored moments. So that is to be 1.2 times 30. So 30 kilonewton meters, that is to be for the dead load. So plus 1.6 times 55. So this 55 right here is your live load. So equal sign 1.2 times 30 plus 1.6 times 55. So our answer for our MRX would be 124. Okay, and if we are to solve for MCX, so MCX is equal to phi-mn, since we are to use LRFD, phi-mn. And for us to solve for mn, we must check if it is under zone 1, 2, and 3. And for us not to take time, I have already solved for the value of LP and LR. So your value of LP is equal to 1.76 RY times square root of E over FY. So you already know that. And if you forgot, just watch our previous recorded lecture. Okay, and if you can see here, our LB, our unbraced length is equal to 4 meters. So 4,000 mm. So 4,000 mm. And the value of our LR is 4.91 meters. So 4,910 mm. And our LP is 1.47. So that is to be 1,470 mm. And as you can see, our LB, which is this, is greater than our LP. And it is less than our LR. So going back again to this particular slide right here, if your LB is is greater than LP. So if your LB is greater than LP and your LR is, your LB is less than your LR, you are to consider, you are to solve for your MN using the formulas in zone 2. So zone 2 na tayo ngayon, and from that, lateral torsional buckling is already present in our design. So from that, once again, if we are to consider zone 2, we would be making use of this formula right here. And our MP, so by the way, we already have the value for CB. So for CB, that is equal to 1.0. And as for our MP, we will solve for that later. And for the other parameters, I would just be copying this to the next slide. So this would be the factors, the values that we would be using. Okay, so let's solve for MP first. So MP, or your plastic moment, is equal to Fy, which is 345 megapascals, times Z's of X, which is 600 times 10 raised to 3. So 600 times 10 raised to 3 millimeter cube. Okay, so solving for this. So 345 times 600 times 1,000, and our MP here would be equal to 207. How many zeros is that? 2, 3, 4, 5, 6. So 207 million. So our answer for our MP is 207 million. And I would just be storing this to A. So shift store A. So there, I have stored this value to A already for the simplification of our formula later. So after that, so direct substitution. So for our MN is equal to CB, and our CB is equal to 1.0 times MP, and our MP is equal to A. So I have already stored it to A minus, so A once again, minus 0.7 Fy, and our Fy is 345 times Sx, which is our elastic section modulus, and our elastic section modulus is 531 times 10 raised to 3. So it is this value right here. And after that, we would be multiplying this by LB minus LP over LR minus LP. And you can use either millimeters or in meters. It won't matter because their unit would just cancel out. So I would be using meters this time. So if I am to use meters, LB or LB is to be, so I'll write it here, 4 meters. Oops, nag-iba yung color. 4 meters minus LP, and our LP is 1.47 divided by LR. Our LR here is 4.91 minus 1.47. So solving for this equation, we would be having a nominal flexural moment of, so A minus 0.7 times 345 times 531 times 1000. So closing parenthesis times the ratio of our lengths, which is 4 minus 1.47 divided by 4.91 minus 1.47. And our answer here would be 149.072193.3 Newton millimeters. And for the value of VMN, we would just be multiplying this by a reduction factor of 0.9 since we are to use LRFD. So 0.9 mn. So let's just convert this into kilonewton meters. So divided by 10 raised to 6 to be converted into kilonewton meters. So looking at the calculator to your left, I would be multiplying this by 0.9, and I would be dividing this by 1 million. So our answer here would be 134.16 kilonewton meters. So we already have the value of our VMN, and our VMN, by the way, is to be your MCX. So that is using this equation right here. Okay, so for the values of our PR and PC, so our PR is 530 and our PC is 1769.85. So I would just be writing them in the last slide. So PR is equal to 530 kilonewtons. Our PC is equal to 1769.85 kilonewtons. So our M's of Rx, that is to be this 124 kilonewton meters. So 124 kilonewton meters, and our MCX would be this 134.16 kilonewton meters. So 134.16 kilonewton meter. And since we are to, since our ratio for PR and PC is less than 0.2, we would be making use once again of this ratio right here. Oh, by the way, it is greater than 0.2. Okay, so if it is greater than 0.2, so our interaction formula that we would be using here would be PR over PC plus 8/9 times MRX over MCX. So if you have your bending moments about the y-axis, you would be adding the fraction that is only concerned with the y-axis. But since we don't have any bending along the y-axis here, this is enough. So substituting known values, so I would just be substituting them in our calculator to your left. So that is to be 530 divided by 1769.85 plus 8 over 9. So 8 over 9 times MRX, and our MRX would be 124 and our MCX would be 134.16. And solving for this, our answer here would be 1.12. And 1.12 is definitely larger than 1.0. Though it might be close, but it is still not enough. So if it is greater than 1.0, it means that our section, which is W10 by 30, if I'm not mistaken. So is it W10 by 30? Yes, our section, which is W10 by 30, is not adequate. So W10 by 30 is not adequate, or inadequate. Inadequate, I should say. So are you guys following?
Yes, sir.
Okay.
Yes, sir.
Okay, so are there any questions?
What would be the remedy, sir? In case inadequate, what is your options?
Sir, increase the size of your section, sir.
Other than that, let's say you're limited to
Okay, sir.
that section only. Let's say
Oh.
that's the only section that's
Okay, sir.
available.
Sir, if you can see here, it is said here that the unbraced length is that of 4 meters. So for us to for us to have a much stiffer section, it is better for us to reduce the unbraced length of 4 meters. So by applying our bracings along the what you call that, the compression flanges and the compression sides of our web, sir. Along, maybe let's divide this into two, maybe for us to get an unbraced length of 2 meters, sir. Or let's say if we wouldn't be having lateral torsional buckling, let's reduce our unbraced length to less than 1.47, sir.
Or you can reduce the load.
Or
Or
yes, sir,
possibly
better yet.
just
If we
reduce the
can
load.
reduce the load, sir, better yet.
Yeah.
Yes.
So let me just advise our students that the board exam would be computer-based examination, possibly.
Oh.
So your batch might be experiencing this. And according to Engineer Bernardo, the head of CE board, she stated that the possibility of situational problems coming up,
Oh.
meaning to say it's not anymore the usual, but let's say it's the usual, like these problems, and then the possible question would be coming like what I've asked, like what would you suggest, or what would be a condition that you would suggest, so that you would be using this. So it will become situational according to her. So I think,
Yes, better, sir.
and I'm thankful that Engineer Manzano is sharing with you his experience also, so that in a way you could also relate to it, and possibly I'm just sorry that you're not able to have your on-the-job training, which is very important also, I believe. Unfortunately, as mentioned by Chair Bernardo, that would be the cases for design problem. So I would like to encourage you to expand your horizon by observation. When you go to the construction, construction, if you see any construction, ongoing construction, be observant, ask questions, tell your instructors how you feel, tell them possibly your questions. And that's one way for you to be able to, I think, pass the exam. So, 2:30 na, sir. Mag-out
Yes.
na ako.
Sige,
Thank
sir.
you.
Thank
I'll
you
just
also,
say
sir.
thank you. If you have to continue, do continue.
Yes,
Please do
sir.
continue.
We will, sir. Thank you, sir.
I did enjoy yung computation
Thank you, sir.
part, and then, of course, bago-bago yung mga ngayon, LRFD. Sa amin lang noon, USD, ASD,
Yes sir.
working
Yes sir.
design. Yun lang sa atin ngayon, bago na.
Yes sir.
So,
2015
please
kasi to sir.
also, yeah,
Mm-mm.
even the methods daw, medyo pinaiba.
Yes
And
sir.
problems are becoming more challenging because yung situational na. Okay? So, I would like to beg off and I would like you to thank each and everyone and also to please do continue. Okay, sir, mag-leave na ako ah.
Yes sir. Thank you sir.
Okay,
We,
bye-bye. We'll
bye
see
sir.
you.
Yes, sir.
Bye
Bye-bye.
sir.
Thank you po.
Bye-bye.
Thank you,
Bye,
sir.
sir.
Yeah, thank you rin.
Thank you sir. Okay, so ayun, continue muna tayo. Naintindihan niyo naman yung sinabi ni Sir Winston na in your board exams magiging situational based. So, di ko alam kung dapat nyo bang kabahan, but I think that would be a good thing since you would be more challenged and kapag pumasa kayo, talagang masasabi nyo deserve nyo. And papasa kayo, alam ko yun, tataas ng grades nyo sa akin eh. Anyway, are there any questions? Everyone? Anyone, I should say. Before we, okay, ano yan? What is it? Ay, wala ba? Or napindot lang ba? Okay, so if there are no more questions, let's proceed with the combination of both axial compression and flexural. So, sulitin na natin to para hindi na tayo mag-meet on Friday, no? Okay, so